Hi everyone, Jeffy here and welcome back to Around the World in Many Days. Today's episode is number 14 and it's titled Coasting Along the Coast. Now, let's see what Gladys writes us this time. So here's the preamble. Dear Puzzling, the larger grid is a Fillomino puzzle. And if you look below, you see we have one bigger grid and then a smaller one below it. So the larger one is a Fillomino puzzle. Each of the 6 different letters in the grid F, K, O, R, S, and T stand for a different number 1 to 6. Divide the grid into orthogonally connected regions so that the number in each cell indicates the size of its region. Multiple given numbers can be part of the same region, and there can be regions with no given number at all. Regions of the same size cannot share an edge, but they can touch at a corner. Okay, let's stop there and look at what that all means. So in Fillomino, normally you have numbers in the grid. Let's say this is the number 2. That would mean that this has to be part of a region of size 2. So for example, it would have to be like this. And there could be no region of size 2 next to it. So this would be illegal. Now here we don't know the numbers. We know each of these letters is a different number, but we have to first deduce the numbers. But let's go through the rest of the preamble first and then start with this. So the smaller grid is a star battle puzzle. Place 1 star in each of the 5 regions in the grid so that there are no 2 stars on the same row, same column, or next to each other, even diagonally. We'll go through this again once we finish with the Fillomino. And then there's what we are looking for. So today I have traveled along the coastline and arrived at an ancient fortified town at the end of an impressive mountain-rimmed bay. Can you guess where I am? Love, Gladys. So we are looking for a fortified town at the end of a bay of some sort. Okay, so let's go start with the Fillomino and then look at what the rules of the star battle actually mean. So here we are. Now, in Fillomino, I like to write the number in each cell, so that we have these empty cells. So it would be these would be S's, and then also mark them with these lines, so we know they're separate from these other cells. But I think the first thing we can do is just separate things that can't be in the same region. So obviously, 2 different numbers can never be in the same region because they have to be in regions of different sizes. I think that's all the separation we can do here. And now we see multiple of these have only one option to grow. For example, this K can only grow here, and it can't grow any further. So it can either be size 1 or size 2. This would be size 1 K, and this would be size 2. We don't know which it is, but it definitely cannot be anything more than 2. What else can we say about something here? F also has only one way to grow. So if F is not 1, this is going to be F, and then it's going to grow in one of these directions, potentially. Let's see what else. These 2 also have only one way to grow. And also these K's cannot grow in this direction because remember we see here that K cannot be 3 or more. If we put a K here, that's illegal because we can't make this a size 3 region. So that's immediately disallowed. So is this K here. Oops, sorry. So we can actually draw some edges here. The K's cannot grow in either of these directions. Now it looks like this is going to be T because this is the only way this cell can grow. But that's not exactly the case because remember a region doesn't have to contain a given digit. So this could be, let's say, O is 1. This could be an O, and then just a region of size 1. So it's either that or the T, but it could be a size 1 as well. So just something to keep in mind. But let's look at this corner here. So if this T grows, this is T and S is 1. If this S grows, this is S and the T is 1. So what we know from that is 1 is either T or S. So K can't be 1. So that means K has to be exactly 2. It can't be 1 because then one of these would also be a 1, and all of these have to be different numbers. So we know K is 2. We know this K can only grow in this direction, so that's 2. This K can grow here or here. We don't know which. Let's mark this K here as well. Okay. What about these T's and S's? What can they be? So if this T grows, this means this grows. So T is at least 3. If this S grows, this S grows here, and S is at least 4. Do we know anything better than that? Not immediately, I think. This R also is, it can't be 1 because 1 is either T or S. It has to grow in this direction. So we actually know R is at least 4. Now we have the numbers 1 to 6. So R could grow in this direction. This would make it a region of size 6. Or here, same story. And size 6 is allowed. Size 7 is not. There's no 7. But we know R is at least 4. We know F grows, so it must go here. We draw an edge here. Do we know which way it goes? We actually don't yet, because either of these could be 1, and even if this is not the one, this doesn't have to block these Fs. So we don't know that quite yet. What about this O? Now remember, K is 2, so whichever here is not the 1 is going to grow here, and it can't be just the 2 because K is already 2. So it has to grow here as well, which means O can't grow in that direction. O must come here. So O can't be 1 because 1 is either S or T. O can't be 2 because K is 2. So O must grow in this direction. And now if we look at this, what this O did, now let's say S is not the 1. It grows here and here. So that's the 3. And that's the most it can be. So S and T are going to be 1 and 3. Now what this means again is these are going to be taken by the S or the T, which we don't know yet, but we can draw these lines already. And we also know now that 1, 2, 3 have been taken. So O is going to be at least 4, and so is R, and so is F. So they're going to be the 4, 5, and 6. Now, can we do something better? Now, we don't necessarily know the O goes here, because the O could go here and then make it a 4. So this is not necessarily an O. This R does need to grow. R is at least 4. So it's going to go here. And that's going to limit this 5-cell area here. Because T and S are 1 and 3. So there's 2 options for this 5-cell region here. So we have the 1 and 3 here. These are going to be either S if S is 3 or T. No, not necessarily actually, but 3 and 1 are going to take 4 out of those 5 cells. Now what's the last going to be? It could be this K, could be this R, or it could be a 1 here, which would then make S the 1. But no, actually, if we look at this, we now know that S can't be 3, because if S grows, it's at least 4, and there's no way to make 4 from this S. So S can't grow from here. So S is 1, T is 3. And we can surround all these S's because they're ones. And we can grow all these T's now. Now this must grow, this T must grow here, and that completes a 3. We can draw edges, and this also can't grow here because this would touch another area of size 3. We can't do that. So it can only grow in that direction. T, again, can't grow there. Would touch another area of size 3. That's an edge. That's F is not the same as T. So T can only grow here. So that's going to be our area of size 3. Now here we have another area of size 3. We can't touch this with another area of size 3. So we have to divide this. 2 ways of dividing it, like this and like this. If we do this, then there's a 1 touching a 1. This would be an S, and that's an S as well. Can't do that, so we do this. And we can write the letters there as well. So S is 1 and K is 2, so this is KK. What else? Now we can go further with this F. These F's have to grow here. F is at least 4 still. O is at least 4, so it must grow. Now F has to have a 4th F, so it goes only one way to go. And let's draw some lines here. Oh, and we can draw a line here as well. We can't grow, this T can't grow in this direction because we can't touch these other T's. So it must grow downwards, which again, in turn makes this O now grow in this direction because O is at least 4, not the P, the O. Separate these and these. Now F could, if F doesn't have to grow anymore, it also already has 4. It could be a 5 and grow 1 more. It can't be a 6 because if we take this with the F, we don't have enough room for this R. This R is at least 4. So in fact, we can grow this R a little bit. Even if it takes this, it needs 3 more. So 1, 2, and 3. These have to be R's at least. Could grow in this direction, but at least here, at least these are necessary for the R. So that makes F either 4 or 5. It can't be 6. Well, now we need a 4th O, because O is 4, 5, or 6. So O grows in this direction. The T now only is one way to grow. It's there, and that completes the T, which is 3, so we can surround that. Now here, we see this O, and whichever it has to grow, and whichever way it grows, it touches these 4 O's, making a 6. So O is 6, based on these. Now, do we know which way the 6 is going to be? Is it this or this? Yeah, actually, we do know. If we put an O here, which is wrong, the R is at least 4, so that would be an R, but now the R is 4 and F is 4. And these have to be different numbers, first of all, and second of all, we can't touch. 2 regions of size 4 can't touch. So this is not an O. So the O goes here. That is now a 6 completed, like that. And now either this F is 5 and R is 4, or this R is, what did I say? Either F is 5 and R is 4, which would make this R and this F. Or R is 5, which would make this R and this R. In either case, this is going to be an R. But do we know whether R is 4 or 5? Now these are the only unknowns at this point, F and R. Everything else is known. The 1, 2, 3 are known, and the 6 is already known. Looking at this cell should tell us whether R can be 5. So if R is 4, what are we doing? We are surrounding this like this, and now we have a regional size 1 next to regional size 1. That's illegal. So R must be 5. So this can't be 1. It has to grow, and it has to grow into the R, so making it an R. And now since we have 5 R's here, we can surround it because R is 5. And this is also a size 5 R. Now let's look at these. Since R is 5, even if it takes this, it has to take this would be the 4th R, and this would be the 5th. And now we see it can't take this because these are already 5 R's. There we are. There we have a area of size 2. Those are going to be K's. Obviously can't divide it because the 1s would then touch. And this area is size 6 and O is 6, so that's just going to be filled with those. This K needs to grow. It's size 2, it goes down because it can't touch these. And these 3 are then just the T's. Okay, so that is our finished Fillomino grid. Now, we didn't write anywhere what letters are what numbers, but I don't think it makes a difference. We can just we're not going to need that information. So let's go back to the preamble and read the rules of the other puzzle, and then solve that one, and then come back to these to get the final answer somehow. So let's go back. The smaller grid is a star battle puzzle. Okay, so we place 1 star in each of the 5 regions in the grid, so that there are no 2 stars on the same row, same column, or next to each other, and diagonally also counts as next. So where's our star battle? Here it is. So let's make this a bit bigger. So we're placing stars in these regions. So there's 1 star in each of these. And let's say you have a star here. So you can't have anything next to it in these, any stars next to it, and there can be no stars in the same row or in the same column. So those would all be ruled out by that star. Now this is very, very small and very simple. I'm not sure why it keeps doing this for these dots there, but okay. So this is going to be very simple. For example, if we put a star here, we rule out this cell, and this cell. Those would all be next to this star. And then we would have no way of putting any star in this region. So we could already rule out this cell. There's an easier way to start also. This region here is only on this column. So wherever we put the star here, it's going to be in this column, which means we cannot have another in this column, another star here. Wherever the star is, it's going to block out these 2, which means in this region, there's only 1 place for the star. It's going to be here. And we mark everything that can't be stars, the column, the row, and everything next to it. Now what that means is we're going to have 1 star either here or here. Wherever it is, we can't have another here, because these would be touching diagonally, or here. So these are out, and this has to be a star now, because it's the only remaining square in this region. And now this rules out its column and every cell next to it. Now this only leaves 1 option for this region. That rules out the row, the column. Oh, by the way, this is ruled out as well, this row. The column is ruled out and everything around it. Now this region only has 1 place for a star. That rules out this, and that's a star as well. So that's the solution to the star battle. That was very straightforward, but how are we going to use these to find the answer? And the preamble says nothing about how to find it. It just says the rules of the star battle and then explains what we are looking for. But if you look closely, which wasn't in the editable grid, but it is here on the page. This is the star battle grid, and it has this partial T and partial K next to it. And T and K were letters in the Fillomino grid. So that would indicate that we need to find, obviously this is much smaller than the Fillomino grid, so that would indicate we must find a place for this star battle grid inside the Fillomino grid, so that there's a T to the right of it, and K, T to the left of it, and K to the right of it in these positions. So let's see if we can find a place 5 by 5 where T and K are in these positions. So open up the solved Fillomino again, and we are going to be looking for, now how are we going to do this? I'm going to mark it as with this surface, I think. So we're going to need 5 by 5, and let's see if it's here. If this is the Fillomino grid, we would have T here and K here. Well, that doesn't fit. This is not a K. So let's find a T where, if you count 6 here, we get a K. So not this then. This is T. Not this then. That would be that would have to be a K. Not this. That would be the K. What about this? That would be the K. What about this? This actually works. Now this T and this K are in the correct positions. Let's see if there are anything else. These are obviously, we can't use these because it would be off the grid. No T is here. So this is the only T that works. 5 by 5 goes here, and this is the K. So that would indicate that we need to place the star battle puzzle here. Now let's see where the stars were. And now the most important thing is to pick the right color. Let's use this. Let's use this blue. I think it's clear even with the green numbers. So let's move the star battle to the side so we can see. So we had stars. So this is 5 by 5. The second one is the star here. The fifth one on the second row. The middle one. The first one on the fourth row. And the fourth one here on the final row. So that spells out Kotor. Kotor. So that is our final answer. Kotor is what we were looking for, and what we were looking for was an ancient fortified town at the end of an impressive mountain-rimmed bay. Well, let's look at what Kotor is and where it's located. So Kotor is a coastal town in Montenegro, and as you see here, this is the bay of Kotor, and it has mountains on both sides. So that's where Gladys is now, in Montenegro, and we can see it on the map as well, right there on the coast of Montenegro. So let's look at the addition to our map then. So this was our map. We did Africa, so to speak, and last time we were on Gozo in Malta, and now we have actually crossed into Europe. We are in Montenegro, Kotor Montenegro. So that is our answer this time. And that is all for episode 14. Now episode 15 is going to be called, I'm going to just scroll down because I keep forgetting what it's going to be called, Paranormal Activity. Paranormal Activity, and it's going to be a cryptic crossword and a Nurikabe puzzle. So I will see you for that, and thanks for watching.